Hello everyone, so today we are going to solve a GFG problem which is search in a rotated array. So what we have given here is that we have a sorted and rotated array. So what rotated means is that let's suppose we have an array. So you can see here that 5, 6, 7, 8, 9 are sorted and also 1, 2, 3 are sorted. That means the whole array is rotated from this point, right? So if we can see that in a sorted array we have the element 1 2 3, then 5 6 7 8 9 10, but from here the element after 3 got here. That means that one half of the array is sorted and also the other half of the array is sorted, and then here in between this what we can see that from here left half is sorted, and then from here right half is sorted. So how what we have to do is we have given a key element and we have to find that element index inside this array. So how we can approach this problem is that let's suppose we have given an array like this, which we had already seen, and we have to find this key element 10, and the answer is 5, which is the index of that particular element inside the array. So what we can do, we have to firstly check that if, so here we are going to use binary sort, so binary search. So what we do, we firstly initialize the left integer or the left pointer, and then h is representing the right pointer. So left is 0, right is n minus 1, where n is the index of our array, and then m is the middle element. So what we are here going to do is we are going to apply binary search method. So in binary search method, firstly we calculate the middle element or the middle index, which is basically L plus h by 2, where h is the rightmost index and L is the leftmost index. So here, if our value at index m is equal to key element, then we have to simply return the answer. Otherwise, what we do, if our value at m index is greater than key, that means let's suppose here in this case m is 9, right, and the key is 10. So what we can see here is that the value at index m is less than the key element. So what we do, we just make our L element m plus 1. So here the L comes in the position of m plus 1 index. So here we can see that L plus m is the else case. So here in this case L of m is greater than key, then only we have to actually make our right index m minus 1. But in this case we can see that our L of m is greater than the key element, that's why we are making our L as m plus 1. Now we calculate the mid of these two and then we again check for it. So this is a simple binary search algorithm. So here we have to apply two binary search. So first one is for, let's suppose L of m is greater than L of L. So L is the left index, right, and m is the middle index. So if this is a possible case, then this actually means that our array is sorted from left to mid. So here we can see that from left to mid our array is already sorted. So we apply binary search inside that, and then if we find the key element, then we simply return the answer. Else if this is not the case, then what we do, we apply the binary search for rest of the array and simply return the answer. So let's see the code of it. So here the while loop runs till the point left is less than or equal to the right pointer, and m is basically L plus h by 2. So if our a of m, so if our middle index value is equal to key, then we have to simply return the index at that point, which is m actually. And if this is not the case, then we have to actually check if our a of L is less than equal to a of m, that means that the whole left part array is sorted. So we apply binary search in that particular part of the array. So which means that if our key element is greater than left, a of left greater than or equal to a of left, and if it is less than a of m, then what we do, we just take our rightmost index as m minus 1, and if this is not the case, then we simply make our left as m plus 1, and else what we do, we just check the same for our right array. So what here we can see that if our value at a of m is less than, is greater than, if our or we can say if the value of a of m is less than the key element, and if key element is less than equal to our rightmost element, then what we do, we just make our left as m plus 1, else what we do, we just make our right pointer as m minus 1. So here also and here also we are applying binary search for the left sorted array and for the right sorted array, and by doing this we got our index. And if we cannot find any key value inside our array, then we have to simply return minus 1. So let's try to submit this. So this is the approach to solve search in a rotated array problem. And if you want to assess the code, then you can directly check the GitHub link given in the description. And this is it for this video. Thanks for watching.